First thing first, I'm not a cryptographer. I know about blockchains, but I'm not a blockchain person 100%. I'm a computer networking person, okay? I teach computer networks at Northwestern University. So the good question here is, why the hell am I here and why should you listen to me? And so I hope that by the end of this talk, I can convince you that you didn't waste your time, and basically that this is what I intend to convince you by the end of this in the next 20 minutes. First thing, I claim that we can scale Ethereum today. Not tomorrow, not in 5 months, not in 1 year. You can download our software today, and we are capable of pushing Ethereum's TPS rate to much bigger rates than where they are now. Okay? I understand that you may be hearing about this type of statements for years from different people, learning about different technologies, but my claim is you can do it right now. And as we speak, actually a test is going on where we are actually doing what I'm telling you that we're doing. So the key purpose of my talk here is to tell you what is that we are doing, and so you have some basic understanding, and to kind of be able to download and use our software so that you can utilize this thing that we are building. One more caveat, this is that our solution works equally well for proof of work or proof of stake, any and all other things that people are doing at layer 2, layer 1, and any other solutions that people are, some of which we've heard. I was listening to some of the talks on ETH 2.0 and stuff like that. All of that is going to work. We are not competing with anybody. We are just trying to help this community, which I really have a high opinion of, to actually move forward and actually do some real world things, because scalability is an important thing. And one other thing, we don't require you to change a single piece of code, which I think is a big thing, because that helps you, I mean, that definitely helps with adoption. So I think these are quite big promises, so let me try to deliver at least at some of them, so you'll judge whether I did it or not. So before I move on, why do we need scalability? I mean, I hope I don't need to spend a lot of time on explaining this, but I mean, without scalability, this nor any other community, blockchain community, will be capable of delivering the promise that they have, right? If you have 3, like Bitcoin has, or Ethereum currently 10 transactions per second, I'm sorry, that's not going to work in the real world, right? Because just to, like, as we know, like Visa has 5,000 TPS. If you just count the number of cars in US and you assume that each of them will fill a tank once a day, just for that you need 450 TPS, okay? And for all these super cool and super new applications that everybody's talking about, machine-to-machine communication, smart contracts, all of this stuff, hey, we really do need scalability for blockchains. And for Ethereum in particular, because it is one of the leading, if not the leading, blockchain. So let me tell you something that you likely know, some of these things even better than me, which is, so what are the scalability solutions? So I'll start from the top. There's layer 2 solutions where people are saying, hey, listen, this on-chain scaling is too hard and it's not going to ever fly. So let's just forget about that. Let's try to do off-chain scaling, okay? And so there are many attempts there, and I'm not going to judge on how good or bad they are, on what I think and don't think about them. I mean, that's something that people are working on. So long as people believe in those solutions, it is pretty good, and we are not, again, competing with any of those. If these solutions are successful, we are going to be very happy as well, okay? Then there are these so-called layer 1 solutions, which is, hey, let's make a smarter consensus protocols, right? So Ethereum 2.0 is a perfect example, and there are many other attempts on many other different in many different protocols. So what we are saying is, that's a good direction. Keep doing what you're doing, because we all have the same goal. But what we are saying is that there is a forgotten layer here, and the proof that it's forgotten is because we couldn't even give it a number when we figured out it exists, right? Because layer 1 was already taken, right? Because blockchains are dominated by consensus protocols are so important, And hence, when we came into play, there were even no numbers. So we gave it a layer 0. What is layer 0? Layer 0 is a networking solution. Okay, it's a networking layer, and my claim is that it actually there is a huge, it's a gold mine for scalability. Okay, that is unutilized and forgotten by the blockchain communities, Ethereum as well. And so what we are into is giving scale to blockchains by working on this networking layer. So you can ask yourself, well, okay, that's pretty good, but so what's wrong with the networking layer? So let me give you a few, let me explain quickly, give you a few slides on what I think and what, so what is wrong with the blockchain networking layer, okay? So typically, independently of if you have a proof of work or proof of stake, the problem is the following. You have somebody mining a block or generating a block or finding a block, and then that particular node needs to send this block to all other, to some subset of all other nodes in the system, okay? This again depends on the consensus protocol, but this is the generic problem, okay? And so typically there are some number of peers connected to this origin miner. I'm going to call it the miner. And so this particular block is being sent to all these other miners, okay? So for security reasons and some other reasons, it is good for this network to be as big as possible, and it is good for this network to be randomly connected, because then it's harder to break this network and so on. Okay, so this means that this miner can be, for example, in Europe, and another node could be in China, and a third one could be in South America. That's a good thing from the security point of view. But from the performance point of view, this is a horrible thing. Why is that? Because once you send a block from one node to another, there is a number of different autonomous systems, different networks governed by different people, and hence the performance on these networks cannot be guaranteed at all. This is the internet as we know it, okay? So what does that mean? Well, somebody looking at Netflix somewhere in the middle of the, on some network, that can affect the performance that you're gonna see when you're sending your blockchain, your block from one node to another. Nobody is gonna care and say, oh, this is Ethereum, we have to be careful because this is very important. Nobody cares about that. Right? So the performance can be pretty horrible. Another bad news is that typically for the system to be secure and for us to be capable of really having a secure system, the network needs to be big, right? So the question is, how do you send information in a big network, right? So the default is peer-to-peer, but the trouble is, I told you about the problems that you have on a first link, but once you pass this first link, there are many, many multiple hops in which these peers have to send this information to all other peers in the system, depending on the consensus protocol. And this now creates a large number of places where things can go wrong, okay? In addition to the networks and to these network links, we are now dependent on what other miners are doing, right? Miners may not be just like malicious to mess up with the data that they're sending. Their performance may be just horrible. Right? And the more scalability we need, the more performance you're going to need from these nodes. And the worse performance is, then whoever mined that block is going to be dependent on what is happening in the rest of the network. Okay? And so I think the time is about for me to propose what is that we are doing, how we are doing differently, so that you can see the difference. So what we are doing is we are building a system. We are building a thing called a blockchain distribution network. Blockchain distribution network comes from the word content distribution network, but I figured out like, hey, CDNs, we know what they are, but this is a CDN for blockchains, so if we can have a CDN for blockchains, we're gonna call it a BDN. How does it work? Let me just give you a few steps so you're gonna understand what is different from what you had in the previous picture. So in our case, what we do is we put on a node, we put an open source code, okay, that to a miner or to any other node that is that accesses the Ethereum network looks just as another miner. But this is a local peer that sits on exactly the same machine, okay? And then once that miner wants to send a block or transactions to the rest of the world, it also sends this this block or transactions to its local peer, which is a BlockXrout gateway to our own network. Okay. Now, what happens then is that once this particular piece of data is handed out to the BlockXrout gateway, it connects. This gateway connects to our global network. Okay, and it pushes data much more faster. And I'm going to explain how and why it is capable of doing this much faster, 10 to 100 times faster. And then it propagates these things to the entire network. Okay, and so let me try to explain two key ideas on how do we achieve a really good performance with BlockXrout and what is the difference. I really am going to try to give you the keys. Okay, the first thing that we are doing is BlockXrout is not just transmitting blocks. When a block comes, in Ethereum it's a short block, but still you still have to send this quickly because blocks are coming pretty often, every 15 seconds or so. So you need to transmit that quick. The trick that we are using is that we are also pushing transactions ahead of time, right? Because our gateways are connected to the miners, are connected to the nodes. Whenever a node sends a transaction, our gateway picks up this transaction, sends this transaction through the network to all other nodes in the system, and at the same time assigns a very short identifier, a 4-byte identifier, which is much shorter than what the original transaction size is. Okay. Why is this important? This is important because when the block comes, which is the moment to speed up the performance of the blockchain system, we are capable of significantly reducing the size of that particular block, right? Why is that? Because assume that, for example, a transaction is 500 bytes. Basically, in our world, this becomes a 4-byte piece of data that needs to be sent to our network. Okay, so this is the first and very important piece. So just here, we're capable of reducing the block size by more than 100 times. Okay, the second thing that this is intended to impress you, some very fancy red dots and information showing information propagation. I hope now that you're impressed, I can move forward. The second thing is that we are doing is that we are actually applying some well-known streaming techniques, but we are the first to apply this in the blockchain space. Okay, so the thing called here is cut-through routing. This has been applied in network switches for decades. There is nothing significant in this on its own. However, the reason why we can utilize this technique is that because BlockXrout, we are not checking the validity of blocks. We are not going to be the one to say, this is the right thing. We don't have time for that. We are trying to optimize for performance. Okay? And given that, so basically what we are doing streaming. What this is showing is on the left side, there is a miner which has installed our gateway. It is sending a block to our server. Okay? Remember, the size of this block is much shorter than it would be if it was the raw block, because we are using this compression technique, but it still takes some time to push this block onto the wire. Okay, so this is shown on the y-axis because time is going south here in this particular space. Now, given that our server cannot be at the same location but is a little bit distant, hence it takes a little time for that for the beginning of that block to reach our server. However, what that figure is showing is that as soon as a few bits of that block are received by the middle server, which is BlockXrout server, what happens is that it starts streaming this data immediately before it has received the rest of the data. Okay? And so what can happen is that in this particular case, you can see on the left side, the sender still didn't finish sending the entire block, and the receiver already got first few bits of that particular block. Okay, so this is trying to show. We're seeing this in reality. So this is we are actually making it much faster. So here we get another order of magnitude improvement. Okay, so with more than 100x in the compression and more than 10 times quicker propagation of blocks, we are capable of pushing things to more than 1,000 times. Okay. And so to summarize, There are three important things here. Number one, the data that we are sending in terms of blocks is much shorter. Number two, instead of having a large number of places where things can go wrong, here things are much more simpler, right? Because you have the access block, you have the network, you have the other nodes receiving it. And the third time, if you can, the third important thing here is that all nodes are directly connected to all other nodes, right? You're no longer dependent on whether somebody is running the right code on their Ethereum node, whether their performance is good, whether that machine is right or wrong. So we provide a broadcast layer to make it all happen. Now, very important thing. What I hoped to have shown here is that you can stream, we can significantly improve the performance of blockchains using a blockchain distribution network, okay? However, if you ask yourself, like, this shouldn't be a huge surprise. Why is that? Because, like, Akamai is a content distribution network that serves, or YouTube pushes 1 terabyte of data every single second. And nobody blinks an eye. Everybody is like, sure, of course, it's 21st century, networks are good, what's the big deal, right? And what I have shown here to you that, hey, you know what? With 10,000 or whatever number of Ethereum nodes, we can make it much faster. It's not a big surprise that you can do this, right? So what is the difference between these two worlds? The key issue with blockchains is that blockchains are this distributed and decentralized system in which no single entity can control what is going on chain. Okay, that's the key idea behind blockchains, right? So the key problem that we have to solve is that once you put this super cool network in the middle of Ethereum, is it still possible to claim that this is a decentralized system, because this network can have a lot of power. For example, if we are evil, or if somebody comes to us and tell us to do this and that, then this is no longer a blockchain network, right? So this really is the key contribution behind our work. And I'm now speaking as an academic. My former PhD student did his PhD on this topic. And so basically, the key design principle behind BioXrout was to design a provably neutral system so that nobody, not even the administrator of the network, is capable of censoring data without that being noticed by the community. Okay? So let me give you a very down-to-earth example of what that means. That means if anybody comes to us and says, hey, you guys, we understand are pushing this blockchain data around the world, we have found out that this particular address are some very bad folks doing some very bad things, like smuggling guns or whatnot. And we realized that if you don't serve that transaction on your network, or tell us whenever you see something along these lines going on, you please tell us and then we'll take care of that. Okay? And this is a possibility that can really happen, and this is what we had in mind when we were designing BioXrout. Okay? Our answer to any such request is going to be, we would be happy to help you, and we equally don't like any of these bad things going on, but there's absolutely nothing we can do to stop this. Not because we wouldn't want to help you, but because the design of the network is such that we are incapable of doing that. Why is that? Because all the blocks, when they're sent by the gateways, are encrypted in our system. Okay? So every block, before a gateway sends a block, it encrypts the block. And the network blindly serves all blocks, and only when the blocks are delivered to the endpoints, only then are the keys distributed among the gateways, and only then is it revealed what was in that particular block. Right? And of course, we have other techniques that we're using, and I'm not going to dive in. I can spend 2 hours on this alone, but I'm sure you guys are going to appreciate me moving to much more interesting topics. So deployment is another important issue. I told you we require no change of code on any of the endpoints. Okay, so we started already working with the big mining pools in Ethereum, and with many other folks interested in making this happen. And then basically, what we provide is an open source code, which is the gateway code, which any of you is going to be able to download from our webpage as soon as September 2019. Okay, even if you're not a miner, or if you're not at all, I mean, if you just want to listen to the Ethereum network, if you just want to send transactions through Ethereum network, you don't have to be a miner so that you want to have the gateway. Any node in the world that wants to listen to the Ethereum network should be interested in getting our gateway, because we are really providing all this information about transactions and blocks to pass through. And so basically, the cost, a good question is, so I mean, this network needs to be funded. So the question is, how does this, so who is paying for the service? Okay, we are not charging miners. This is all completely free to the miners, and we are not ever going to charge any users who are sending tiny amount of transactions. However, our business model is that we plan to charge all those heavy hitters, all those who are going to send huge amounts of transactions in a particular period of time. They are the ones who are going to pay for this. However, the key idea behind scaling, however, is that the fees for everybody should go down. That's the key purpose behind scalability. Otherwise, we wouldn't care about that, right? If everybody would have like $50 per transaction to pay, we wouldn't care about scalability. It's going to be fine. You just pay money and you're fine, right? The key idea behind scalability is that the costs of the entire system goes down significantly, okay? So in a world where we can push things by more than 1,000 times, the on-chain writing on Ethereum blockchain becomes, you can do 1,000 times more writes on-chain. That's the world in which the cost of doing that becomes much smaller, right? And so in this world, despite the fact that, as I said, we are going to plan to charge the end users, in this world, time's up. In this world, basically, they're the ones who benefit the most, because the effective fee is gonna go down by 100. I'm gonna leave you with this. We are currently doing a large test with Ethereum miners, with Ethereum community. Our software is open sourced, and you can download it and you can use it. And so and the great thing is that you can do all of this today, okay? Not in 6 months, not in a year. We are here to scale Ethereum. So with that said, I'll be happy to take any questions if you have, and I hope I didn't, no questions, no problem. Thank you so much. If anybody wants to ask something, I'll be outside and so on. Thank you. Thank you so much.